Hello everyone and welcome back to Statics and Strength of Materials. So, today we're actually kind of getting into the Strength of Materials part of this, so I should probably change this from saying Statics. So, now, Strength. I guess it's not quite that section yet, but we're getting there. We're really building into it now with Chapter 9. Which is a good thing because we're reaching the end of the semester. So, Chapter 9 is all about stresses and strains, things you're getting quite used to having been in this class so long. So first off, what is a stress? I'll give you the really weird jargon answer first, and then I'll give you the kind of, rule of thumb answer. So it's the internal force developed when a body is subjected to external force. It's not completely correct, but that's kind of a good little term there. Usually what people say is the intensity of internal force. Okay. And it's typically described in units of per areas, force per unit area, which is actually the units of pressure. So you'll see things like PSI or pascals, which you probably don't know about, but that's a unit in the SI system. Now, stress, this little equation, right here, that's the stress. It's a sigma, like a little O with a hat. And then you have the load right here is being applied, and then the cross-sectional area that you're looking at. Okay, the cross-sectional area. And there's lots of different ways to talk about this. Now, I wanted to mention what the best way to think about stress is this. If you've got a giant column, a huge column, and you put a 10-pound weight on the top, you're not all that worried. Same material though, and now you have a tiny column, and you put that 10-pound weight on top, you might begin to worry, saying, is that column going to be able to take it? The material is the same. However, you realize that the area is different here. Because there's a whole lot of area here pressing back up. All of it's saying, no, we don't like being squished. But since there's so much area, it doesn't really take all that much force at any one point. It can just be little bits and pieces, and it will be able to hold it up. Because it's spread out. The entire surface is helping out. Over here, though, we have a lot less area, and so it's got to take a lot of force all in a small location. This is what it's getting at. When we're looking at a load right there, we realize that the load is going to cause this, column or whatever it is to change. It's going to squish it down just a little bit. I mean, it's 10 pounds versus a giant column. It's not going to be much unless it's like silly putty. However, we know it's going to do some sort of deformation. It's going to cause a change. And if we want to be generalizing things, we have to get rid of the effect from the cross-section. The cross-section can't be a factor here. We want to just care about the material itself, and say, is that material strong enough for what we need to do? And so instead of looking at forces, because that force will also be affected by the area, we look at stresses, which are independent of area. We've already divided by the area and we've normalized it. Okay? So it's kind of like the average force that it's feeling. It's helping us realize that, yes, the cross-sectional area that I'm putting something on, it matters. But if I'm just trying to find a material, I want to get rid of that dependency. Okay? I want to get rid of that dependency. So, let's keep on going. Other things to think about are sign conventions. Okay? Sign conventions right here. So what we have is tension and compression, okay? If it's trying to make it longer, it's in tension. If it's trying to make it shorter, it's in compression. So these two forces are squishing it in. These two forces are stretching it out. This is tension. This one right here, that one's compression. If I cut it, hi-ya, I'm a ninja, hi-ya. That little section in there will also be in compression or tension. Whatever the other one was, it's in too. And also that force that it was feeling on the outside is felt inside as well. Any particular point I want to. I could cut there, there. They're all feeling the same load. Okay, that's important. The load doesn't just disappear. It's the same load and it's felt all the way through the material. So if the material fails at any point, that's not good. We don't want that to happen. Okay, so that'll be it for this time. Thank you so much for listening. And next time we'll try out a problem with our first equation. Have a wonderful day. Bye-bye.